So, Kappa. Apparently, it's in the Einstein field equations. You got all this A pi over G over C4 convention, yada, yada, yada. Well, I threw that into Chat GPT. Shout out to Chat GPT 4.0. Hyperbolic figure eight knot. And actually, this was the cosmological constant. What the heck am I talking about? Well, my friends, you all know what that means. We conjecture ahead.
Although this is going to be weird, and it's going to be about a different.
Title of the conference was something like "Ground Truth" or "Turtles All the Way Down," and so it seems as though there's one Ruliad. I don't think it rules them all, and it might be just hyper-rulial turtles all the way down.
Yes, it's on the back of an infinite number of hyper-rulial turtles.
Various people are commenting on the outrage of hacking the universe on a MacBook Air.
Hi guys, what's going on? Memes here. Yes. I like my AI generated art, even if this isn't quite the fan. Again, I have trolled her pretty hard, but I don't know. Isn't that just pretty and everything? It's the first time I threw the original hyperbolic vortex equation, one of those early AIs, and it kind of threw like 5. It was kind of creepy. Then again, I'm pattern recognition creature, so I look for those type of stuff and things. All right, so that's not about AI art and everything, but yes, Rick, yes. Are these the droids we're looking for? I can neither confirm nor deny that. But what I can say is I was going back over some old things because, of course, if we're going to change our classification of conventions, because it's like we're going to say, all right, times 10 to the negative 7. But if it's actually like in 0.999999298, yeah, something like that, it usually doesn't make a difference until it makes a difference. And to be fair with Einstein Kappa, they list it to like 13 decimal places, but you're sitting there, you're like, well, if we generally know big G to like 5-6 decimal places or something like that, it's like, how do we get it? I remember doing it like last summer, and basically I just took the straight numbers that they had all the way down the average, you plug it in, and actually that's exactly what you get, or at least to my recollection. I could be wrong. So I went back and did some things. So there could be some wiggle room. And to be fair, I actually need to recompute with all the shows because there's so much variance there. But while looking into it, every once in a while you see something really neat. And I didn't know what to make of it, but I went through it anyway, and I found some interesting things. So we'll delve into it. Again, this is conjecture. This is conjecture on my part. All right, so finding Einstein's Kappa. Link in the doobly-doo below, of course. But let's see. All right, finding out. I'm begging it. What's wrong with me? I can't even read that. All right, let's do this. No, bad memes. There we go. All right, finding Einstein's Kappa. I literally just threw K in there. All right, the Kappa. You have to go through, and we're assuming the Einstein C4 convention. What's that mean? We take the speed of light, C there, and then we raise it to 4 when we throw it in the denominator and everything. And then if you invert that, you kind of get the Planck force, yada, yada. Or there's like an 8 pi. Different rabbit hole. God, I do like the rabbit hole. So, we continue. All right, so it's still learning how to code. I got a few more months until the summer school. All right, so you throw it in there, you get those stuff and things. There's, hey, Fractal, thank you for joining as well. That's, I like the shout outs to Archimedes. Every once in a while, I look back at some of these things, it's like, they were like doing projective geometry and stuff back in it's like thousands of years ago. It's like, kind of seemed to disappear for a while, and now we seem to be coming back to that. Things tend to come full circle, I claim. All right. But yes, Fractal. It is a fascinating evening, but I shall not continue to bloviate like I was. All right. So you get your one Einstein C4 conjections, blah, 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 our dimensions, mass, length, and time. Mass and length is a -1, so that means they go in the denominator. Time goes in there in the numerator. All right, let's get some decimals to S. And this is an interesting thing. Wolfram Alpha, it seems like they threw another digit in here for some reason. It's like, it's different than Codad. I think they changed it. Because I think in CoData it's 0 and then like 1 5 for the error there. Let me see. Yeah, so I got all the things over here. Oh. All right. So, all right, we got the speed of light there. We plug it in. Okay. So, because like, what was it? Yeah, 3-0, and that was like it has like a 4 there, and I'm like, oh, okay, it could be that, but I just found it interesting that they updated to that. Oh, well. But we go through, and all right, we got these numbers there. Blah blah blah. Every once in a while, I'll do it in kilograms of force. I'm like, why are my numbers so far off? And then my dimensions are different and everything. Make sure the dimensions match. That's one of the very confusing things. All right, so it's saying that we're getting it that, but all right. So let's just go down to the actual check. All right. So that was one thing. Actually, I think that was off. So I think I went by. Yeah, this is by the CoData. There. So I throw the stuff in the CoData, and it basically gives us this thing that basically matches the Wikipedia. Because it's from Wikipedia, so obviously it must be right. All right. So what we got? 266 4744 284. Okay, so it gives us exactly what's in Wikipedia. Let me go on. Hey, Buff. Yes. Yeah, dude, the AI art is great. And I'm like, I have no idea. Again, I'm totally biased. But if these things actually have to do with fundamental reality, I just love it. It's like, I don't know exactly what it looks like. AI, take the power of the internet. Be creative. You've read a lot of stuff. Unleash the power of humanity, I claim. And I get Echelon beeping in. I'll make this quick. All right, so I'm going over the old derivation. Full disclosure, I need to go through this all again. I didn't spend like the 5 to 6 hours earlier doing it. I just went back to see if this was at least within range, and then found something that's actually really neat. So let's get to it. Okay, blah blah blah. Let's see our result deviate. Okay, so 1 and blah blah blah. So we're at 43, so we get like the first 5 decimal places approximately or so. Okay. Throw it into our universal. Oh my god, it failed to load. Wolfram Alpha, what happened? Wow. Okay. So we'll move on. Basically, this is the number that we're looking for. I've done this calculation before, so skipping ahead a bit. This is just 2. We raise it to the 5th. That's why I am particular to this. I think it would explain a lot. I'm not sure if it's correct. But again, you go in there, we solve for this, and then it gives you this little number here. Boom. Okay, so you search for that number, blah, blah, blah. Okay, so we're skipping ahead. And some of this path, I kind of lost myself, so I had to recreate it for the next part. But look at these closed forms. We're looking for something that makes sense within our model. Does anybody see anything over here with a 5-dimensional construction utilizing 44 based arrangements? I don't know. Any of these look interesting? I mean, these 2 are mostly interesting to me, but this is the one. CET. What the heck is CET? Let's see if I hit the right thing. No, I did not hit the right thing. Hold on. All right. CET is actually the Embry-Trefethen constant. What the heck is the Embry-Trefethen constant? All right, we go to our friend the Googles. We click on the Embry-Trefethen constant. It redirects us. Where's it? Random Fibonacci sequence. It's almost like you're trying to flip a coin or something. Oh, very interesting. Okay, so this is how you compute it. Basically, it trends towards this number here. Or this is for the Fibonacci. Embry is a derivation or so below. But consider the sequence. There you have it. Okay, so whatever Fibonacci number you're trying to do, you're basically doing plus or minus. So basically, you're literally doing a fair coin toss, an actual fair coin toss. And then -1, blah, blah. Basically, it would be that number the one before that. So whatever number you're plugging in, that's your n. So whatever it is, blah, 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 plus or minus, and you're just alternating. Gives you that number there, blah, blah, blah. Go through all this. Basically, long story short, this is the Embry-Trefethen constant. Why are there only 5 digits? Apparently, it takes a lot of computational power to continue onward to get that next digit. Thad reverse computed this, so I think he has an extra 3 or 4 significant digits. So if anybody knows how much computational time on like a supercomputer it would take, like if it's something not crazy, I'm willing to see if we can get like an extra few digits. Or if I could just run it on my computer for like a month or something like that, I'll do that too. It's because I mean that's math. That just requires computation. Why has nobody done it? I don't think anyone's ever had a reason to figure out the 6 significant digit. I mean, who would care? If it takes 10,000 hours of computer time, I think people have higher priorities. Just saying. My opinion there. But let's see. All right. So we go. Okay. Sorry. I lost my. Okay. So what's the interpretation? Okay. Let's just go through there. You get this. All right. So my thing is this: we're looking at this terminal action. We're figuring. All right. They got the Shoutout. What's Shoutout? That's the big number. That's the 3.6. Interestingly, there's I think about 7.8 electron volts separating. If you take Shoutout and Shoutout and you square them, and you do, it's pretty close to the proton and the electron mass difference. It's off by, I think it's just actually no, it's a couple. It's not an electron volts in that one. I'm thinking of another calculation. But essentially, I'm like, all right, it's a 5-dimensional model. Okay, we got 5 dimensions times the Embry-Trefethen constant. I'm like, okay, what's that doing? It's setting up a sequence. You're taking it to the limit, plus or minus something. You're just continuing to iterate. It's like fair coin toss. And I'm like, so basically, you're sectioning it off like it's plus 1/2, minus 1/2, plus 1/2, minus 1/2. They change it? But basically, I'm like, all right, got something in there. And oh, yeah, it's 44 derangements. It's like, all right, 44 base derangements. All right. So the whole thing, let's plug it in. Let's actually get the numbers. All right, it tells us it's Kappa, but okay, there's some deviation here. All right, let's see. So we got 2, and again, this is the average for there. So realistically, we need better measurements. We need better measurements to help confirm all this and everything, but this is a pretty good guess. And I'm going to explain why. Don't just know that we want to line up as many numbers as we can and have a reason for it. Why? Because you can line up all the numbers if you want. You can like create any number if you're given enough time and complexity, but we want to do it as simple as possible and be able to explain as much as possible. That's my claim. All right, so we got 207, 6647, 4427. That's 28. All right. But it's 28. Okay, that's basically all right. So it deviates. There's a 13 significant digits. All right, so like the 11th digit. That's not too shabby. It only used to deviate by, I think, like literally 1 at like the last digit when we did times 10 to the -7, that convention. But we're going to do a thing and we're going to claim it's a thing. We got to go through and make sure it's a thing, right? All right. Here's something crazy. I looked at this while I was just redoing the search, and you get some cool things. To be fair, I didn't go through and compute all these yet because I need to do a full organized search if I'm going to go through and do this. But I need to revamp the website. I need to add so many different things. And I need to finish this video. But that's some cool stuff. But I noticed something. This was not all significant. At one point, there were a lot of significant digits. I got this right here. I'm like, that's the mean volume of a tetrahedron in tetrahedron. So basically, it's this thing. Apparently, when you're picking a tetrahedron, if you're doing a tetrahedron in tetrahedron picking, oh, this is actually maybe making more sense now. It gives you this number. Basically, when you go into Wolfram Notebook and you look for a generalized tetrahedron thing, if for some reason gives you this 13 divided by 720 minus pi squared over b. I'm not sure anybody knows why. There might be. I'm open to some clues, but for some reason, this is a tetrahedron in tetrahedron volume. Okay. Why the heck is it minus this? Because to be fair, again, it got it for a lot of integers for this number. So I looked into that. I'm like, all right, what does that have to do with it? Is there any closed form? Again, I'm getting into closed forms within closed forms here. I'm just a crazy person. But I thought it interesting. So I delved deeper. All right, so popped up. Okay. That's literally what I say. This popped up somewhere and seemed quite odd. So that's the mean tetrahedron and tetrahedron thing that we saw there. Yeah. Okay. What does this have to do with anything means? So I looked at the 95 over 977. That's interesting. It's interesting for two reasons. And again, just numerology. I'm not sure it means something. I may actually have an interpretation that I didn't have when I first started this. Figure 8, not hyperbolic volume. All right, you get 5 over 2. It's like, all right, that appears to be a potential closed form for, I think, either time or space, except 5 over 2 for the Giesecke constant. And that 27 over 5, I'm not going to, I did a derivation that I haven't released yet because I forgot the prettier version where Thad made the math look prettier. But I literally had 27 times the square root of that tetrahedron thing before. And it has to do with charge. So I got this. I'm like, that's interesting. All right, so you plug that stuff in, yada, yada, yada. Don't worry about all that. Numbers, numbers, numbers. Again, my math could be wrong. And I put in all the different symbology. I haven't fully encoded that rest yet. So I just pulled literally this number from up here. Just full disclosure. Should be, it's from the guy above. Where is it? Did I delete it? Oh my god! I just pulled that number out of my butt. Oh no, here it is. Okay, means you're pulling stuff out of your butt. Not right now. Hopefully not for a while. I'm not a doctor, but let's see. All right. So we got this. Okay, we got those numbers there. Okay, so I plugged in the number there. We get these things here. It tells us there's a kappa. So we have 207, 207, 66, 47, 44, 282, 285. Okay, that deviates there. Oh, that actually got more significant digits. And again, what's the terminal action there? Again, this is when you write this out. Hold on, I'll actually do it. Okay, I lied. I'm not actually doing it. Okay, so basically you have your. Oh, no, we can do this. We'll copy this here. All right, so we have our 8 pi, our 8 pi g, blah, blah, blah. Oh, they broke the notebook means. All right, so we got Einstein. This is our primary action. We're claiming that if we're following that as a template out, it was probably going to average that. So it would be 8 pi g C4. When you write out the dimensions, it literally boils down to, where's the head here? It's after the broken one? No. Yes. It literally just comes out to 8 pi, and then g over C4, you cancel out to time squared, length of the biggest one, mass to negative 1. You break down those dimensions, and then we solve for our terminal action, which would be that 5. Oh, you probably just put it. Oh, let me put it here. No, it won't let me paste. All right, but basically all we do is we do 1 plus that. Let's go to the bottom. Figure 8, not volume. Blah, blah, blah. Oh, excuse me. Now we do 1 and then there'll be plus, and then you have the volume, mean tetrahedron volume. You would have that figure 8 knot thingy, which this construction there, and then just times J2 raised to the 5th with the inversion there. Okay. I just think it's interesting. How could I even explain this? I'm like, this thing is made of tetrahedron. Why is it being subtracted from a tetrahedron? Okay. Crazy, absolute conjecture on my part. I remember from one of the Wolfram Institutes at one point, one of the fellows, Richard, was like, when I think of hyperbolic space, I think of it as negative space. And I'm like, just according to that, my interpretation would be, how do you get negative tetrahedron if volume? The thing's going in on itself, doing some crazy action like that. Personally, I'm a fan of the M breach of Pfeffin thing because it's like, all right, 5 M breach of Pfeffins. So you got, all right, 5-dimensional components, plus or minus, plus or minus, plus or minus. So they're going to balance. If we could believe there's going to be that figure 8 knot, that complement there, as literally, I would claim, at least according to eternal cyclic cosmology, to my best guesstimation right now, looks like it's a prime mover. Why? That thing's zooming around. And it's bound together by 8-dimensional logic. I'm like, if we got a 3 plus 1 dimension here, if you got something like, I don't know. I'm just saying, what would be a way? And again, I'm personally a fan because it's beautiful. Because you get massive hypersphere, you get all the stuff and things going along. What happens when something comes along there? What happens if it's a star? I would say it's probably going to be a very interesting place in our realm of persistence. Also probably means that there might be hypermassive black holes out there. There be dragons, I claim. So what happens if one of those starts getting sucked up? I don't know. Might that look like quark, gluon, plasma? Perhaps a whole bunch of neutrons, like a neutron decay cosmology, are being fired up. Coincidentally, the current estimate of the vortex's throat is right around the magnitude of the Planck charge in length, which is coincidentally a little bit smaller than the radius of the proton, the classical radius. Why are the 2 radii for the proton on Wolfram alpha? Why does the electron have a classical and Bohr radius? It's almost like you got a circle within a circle. Only could figure out how to fold a couple of circles together in some simple method. I think it's an oscillatory, network emitter engine. I think that thing's whirling around, shooting out stuff that I would say, to our observation, probably will look like a Big Bang. So now that I've committed cosmological sacrilege, but subcycle. That's very. You look at how much people did on this stuff. Oh my God. I need to iterate out, or maybe rent some commuter time. But all I know is it's a crazy time. Things be changing. We got some new tools. I know Simon's Observatory, shout out to Professor Keenan, is coming online a little bit later this year. They should be getting first light anytime. And maybe we'll see some B modes. I need to figure out before then what the heck I should be looking for. Or at least make a claim one way or another. But should be interesting. But that's all I got for right now. Peace out, everybody. Take care of yourselves. It's a wacky and wild world out there. But I think there's some great stuff coming. All right, Clay. Peace out, everybody. I got to end the show. Professional YouTuber, everyone. Peace.